In this video, I'll talk about gas laws. Three laws: Avogadro's law, Boyle's law, Charles' law. Avogadro's law tells us volume is proportional to the number of moles for a gas. Boyle's law tells us volume is proportional to 1 over pressure for a gas. Charles' law tells us the volume of a gas is proportional to the temperature. How do we memorize these three laws? Simple. You see A, B, C. It tells us the volume is proportional to N, 1 over P, and T. N, P, T are also in alphabetical order. Now let's repeat. V is proportional to N, V is proportional to 1 over P, V is proportional to T, therefore V is proportional to N, T, and 1 over P. Therefore V is equal to a constant times NT over P. That constant is R. R is the gas constant. Or we can simply put PV equals nRT as the ideal gas law. What's the value of this constant R? R is equal to 8.31446 joule per mole per Kelvin. This is the SI unit. 1 joule is also equal to 1 Pascal times 1 cubic meter. R is also equal to 0.08206 liter ATM per mole per Kelvin. Why so? 1 ATM is 101,325 pascals. 1 liter is 0.001 cubic meter. Therefore, 1 liter times 1 ATM is 101.325 Pascal cubic meter, or roughly 101.3 joules. So if you use 101.3 multiplied by this number, you will get 8.314. Now let's work on two example problems. First, let's calculate the volume of 1 mole gas at the room temperature and 1 atm pressure. The room temperature is approximately 25 degrees Celsius or 298 K. So we just use this ideal gas equation, PV equals nRT, or volume equals nRT over pressure. We plug in all the numbers. We do not have to use the SI units, but remember, we have to use consistent units. If we have ATM on top, we better have ATM on the bottom. Therefore, we're using this 1.0 mole times 0.08206 liter ATM per mole per Kelvin times not 25 degrees Celsius but 298 Kelvin divided by 1.0 ATM, so that this ATM and this ATM cancel, the moles cancel, mole and mole to the power of -1 cancel, Kelvin to the power of -1 and Kelvin cancel. The only unit left is liter here. Now we just need to do numerical calculations. This number multiplied by this number, you get 25. So the result is 25 liters. 1 mole of gas has a volume of 25 liters at the room temperature and under 1 bar or 1 atm pressure. Remember, 1 bar and 1 atm are very close to each other. What about the standard temperature? The standard temperature is 0 degrees Celsius. At 0 degrees Celsius or 273 Kelvin, you need to replace 298 with 273. And then the volume is roughly 22.4 liters. Now you can tell that when the temperature is higher, you have larger volume. When the temperature is lower, you have a smaller volume. Now, let me ask you another question. What if you have a gas, and I don't tell you what the temperature is or the number of moles is? I will just tell you I'm going to increase its pressure. I'm going to increase its volume. Both the pressure and volume of this gas double. How does its temperature change? The result is the temperature increases fourfold. Why? PV equals nRT. So T is proportional to pressure, T is proportional to volume. If pressure doubles, volume doubles, then T quadruples. I assumed that this N is a constant. We're talking about the same gas, same amount of gas, and also R is a constant. Therefore, T is proportional to the product of P and V. Now I'll let you work on one practice problem. When the temperature doubles and the pressure drops by 50%, how does the volume change? The answer is here in font size 2. Here's the hint. Volume is proportional to temperature, so if just the temperature changes, the temperature doubles, then volume will double. Volume is inversely proportional to the pressure. So if the pressure drops by 50%, then the volume should increase.